Welcome to qnawire.
Hello friends, here it is given the coordinate axis shown represent the principal centroid axis of inertia of 3000 pound. So mass of the space probe is given 93.17. We will convert the weight into mass by dividing with 32.2. Having radius of gyration kx, ky, kz, its initial angular velocity is 0. When meteorite of mass 5 Oz strikes on its one of the panel at point A. So this is the point of A. Then meteorite emerges on the other side of the panel with no change in direction of velocity, only its magnitude reduced by 25%. If the final angular velocity of probe is 0.05 radian per second minus 0.12 radian per second j cap plus omega z k cap and x component of the resulting change in velocity of mass center of the probe is minus 0.675 inch per second, we have to calculate omega z of final angular velocity and v naught relative velocity of meteorite striking the panel. Let us start solving it. Position vector of point of impact Ra will be 9 I cap plus 0.25 sorry 0.75 k cap fit. Initial angular momentum initial linear momentum of meteorite P naught of meteorite will be m v naught. M is given 0.009705 v x I cap plus vy j cap plus vz k cap. Initial angular momentum about origin Ra cross I cap j cap k cap r vector 9 fit 0.75. I am writing in terms of mass of meteorite. Later on we will substitute the value. So it will be m minus 0.75 v by I cap plus 0.75 Vx minus 9 Vz k cap plus 9 By k cap. See equation 1. Final linear momentum of meteorite, it would be 0.75 of mb naught. So you can take the 75% of this. So it becomes 0.007279 Vx I cap plus Vy j cap plus Vz k cap. So final angular momentum of the meteorite about the origin about origin, it will be it becomes Ra plus 0.75 of mb naught. So directly we have solved above. Directly only change in factor of this, all other factor will remain same. So only change will be here. So you can write, I am putting it directly, it would be 0.007279, or that we can put later on. Only I am writing in terms of m because here I have written in terms of n. So you may write 0.75 m minus, there will be no change in these parameters. So we can write as it is 0.75 v by I cap plus 0.75 Vx minus 9 Vz k cap. Sorry, it has to be corrected. It is j cap. Written mistake. Plus 9 v by k cap. This is your second equation. Now we have to apply conservation of angular momentum. Initial angular momentum of meteorite plus initial angular momentum of the probe, which is 0. Final angular momentum of the probe plus final angular momentum of meteorite. So first we will calculate this value, angular momentum of probe final about O. So it can be written as Ix omega x square, Iy omega y square plus Iz omega z square. Ix is m probe kx square omega x, that I have written Ix omega x, Iy omega y. Angular momentum is defined as product of moment of inertia into angular velocity, and moment of inertia is mass into square of radius of gyration. Mp ky square omega y kz omega z. So this, substituting the value, you can simplify. Mass is 93.17. We can take common because each term having kx is given 1.375 whole square into omega x, which is given to us 0.05 I cap plus ky 1.45 1.425 square into omega y minus 0.12 j cap plus 1.250 square omega z. So solving this equation, you will get final angular momentum of the probe about O. You can write 8.8075 I cap, 22.703 j cap plus 145.58 omega z k cap. Now substitute the value for conservation of angular momentum in equation 3. We have to use the equation 2 first, second and fourth. So we can write in equation 3, we are substituting the value. So you may write 0.0009705. This is mass of meteorite. Vx I cap plus b by j cap plus bz k cap is equal to, here we are using conservation of momentum, 0.007279 Vx I cap plus b by j cap plus bz k cap plus 93.17 0.05625 j cap b dash j k cap. So from here you will get equating the coefficient of I cap, you will write 0.00242 Vx is equal to minus 5.2408. So Vx you will get minus 2160 feet per second. J cap you will get 0.002426 B by 2B 93.17 B by dash, and K cap 0.00242 Vz is equal to 93.17 B dash Z. This is equation 5. This is 6. Conservation of angular momentum we can apply. You may write 0.009705 minus 0.75 B by I cap plus 0.75 B by, sorry, Bx is there, minus 9 Vz J cap plus 9 B by K cap is equal to 0.007279 minus 0.75 B by I cap 0.75 Bx minus 9 Bz plus 9 B by K cap plus 8.8075 I cap 22.703 J cap plus 145.58 omega Z K cap. Now again you equating the coefficient of I cap, J cap, K cap. So I cap having the coefficient minus 0.001819 By is equal to 8.8075. So from here value of By you will get 4840.5 feet per second. If you equate the coefficient of J cap, you may write minus 0.02183 Vz plus 0.0018195 Bx to be minus 22.703. So from here you may write Bz to be 0.0833 Vx plus 1039.8, and Vx already we have measured. Vx is minus, let me write it properly, just a moment please. Vx is minus 60 plus 1039.8. So on solving it, Bz you will get 859.8 feet per second. Now, equating the coefficient of k cap, you will get minus 0.02183 Bz is equal to 145.58 omega z. So from here omega z will be minus 0.2183 upon 859.8 divided by 145.58. So omega z will be minus 0.726 radian per second. This is the one of the answer. And velocity of meteorite V naught will be minus 2160 I cap minus 4840 J cap plus 860 K cap feet per second. So this is the answer of B part of this problem. Thanks for watching it.